Hello everyone and welcome back to a YouTube channel for OQLIS, the data insights people. And today we're going to look at a brand new tracking dashboard we've been working on recently. I'll run you through a demonstration of what OQLIS is capable of, explain the architecture behind it, and show you exactly how you can replicate this automated functionality for your own pipeline. Let's dive in. So, the idea behind this project was to create an internal metrics tracking dashboard. We want to track how many dashboards exist on the software, monitor client instances, and understand user metrics. Specifically, how people are actually using OQLIS. By understanding this, we can deliver even better, more proactive service to our clients. Because we are dealing with internal metrics, we're going to focus entirely on the functionality and the architecture today, rather than the raw data itself, as you'll be working with your own raw data for this project. What matters here is the highly scalable automated pipeline we built to get this data into OQLIS. So, how did we build this? The process is powered by a Python script, which I'll show you now, an OQLIS IoT endpoint, and an OQLIS recipe to take the package, the JSON package that comes in, which I'll talk about right after this, and which is then flattened throughout the OQLIS recipe, which I'll also show you in the OQLIS instance. But the real magic is how the Python script knows where to look. We didn't want to hard code every single client database into our script. Instead, we use a control table that we're going to use to control which tables are used and loop through to acquire that data from the database, which we want to send via the endpoint into the OQLIS instance. When our script runs, the very first thing it does is query this control table. It asks, give me the list of all active client databases, their domains, and their plan types. Once it has that master list, it dynamically loops through every single database to extract the data we need. This means as we add new clients, the script automatically scales without us changing a single line of code. So next, I'm going to give you a run through of what the Python code can do, what it does, how it is set up so that you can replicate that on your end. So let's dive into it. All right, welcome to the Python code. And here we will show you how the magic works into running this Python script, what the logic is doing, and how it loops through the database so that your data can be acquired from your database, packaged into a nice JSON file, which is JSON, a JavaScript file that makes transferring data or sending data very convenient. So to start with, we import all the necessary packages. Since this is a MySQL database, we are using MySQL connector to make this connection. First, we start with the configuration, which is MySQL host. That is your IP address for your server or your database MySQL port. Since this is a MySQL database, 3306 is the standard port number used for this database. MySQL user is the tracking user username that you used for your database or server to log in, and your MySQL password is the password that you use to log in with. Then the control database is where your client configuration is listed, so that the Python code acquires this list, so it knows exactly which tables it has to loop through later. So this is basically the limit of what you want to pull into your JSON file and later into OQLIS. Your control table, as seen here, that's also very similar to the control DB. This is also the tables you want to run through and is limit to what you want to pull into your file so that it doesn't just pull in random values you do not want in your data set. For the IoT configurations, a hashed out line was a postman test, which you can use to test and to make sure the JSON file sends correctly and that it receives at the other end before you go into your OQLIS IoT endpoint. So this was the OQLIS URL used, since this is tracking.oqulis.com instance, the IoT module and the endpoint. And then the endpoint good is a unique name I'll show you later in the OQLIS instance itself, and the device ID is just a name that you can know which device it comes from, what is sending the data, so that you can better manage it at the other end. So the target tables, these are the tables that we want to pull into the data set and want to loop through. And the target tables allows us to limit the amount of tables we want to pull in, since we are only interested in these tables here. And then the bunch of functions you have to create. So this is the definition get database connection. It establishes a connection to MySQL, and optionally it can also connect to a specific database in your MySQL server. The get client list, so this is a function that runs through, this is that's responsible for the looping through all the databases so that you can get and pull in your data. So this part here, this query, is we explicitly select only the columns we need. So as you can see, this is a SQL query we have written in Python, which injects into the database so that we can acquire the necessary data we need. And then for row in rows, this is the part that runs throughout the control DB and control table and fetches the necessary data that we need. And then collect counts, this is also a loop that runs through all the databases, and it runs through and counts, and that is the data that we are receiving from this loop. So as you can see, this is the SQL connection we are running in the database to acquire the data we need. So it runs the loop and that it sends back our data. Then next, the post to OQLIS function, which includes the GUID and payload string. So then your post to OQLIS function, which includes the GUID and payload string. And this is the location that the data is sent to in your OQLIS instance. So as you can see here, that you're going to have to do an authorization in the OQLIS instance, which is the endpoint GUID name. It's also a username, and then also the endpoint password, which I'll show you. And then here, this is the main function, which then triggers the other functions we have set up at the top and runs through all the loops, acquires the data. And then here at the bottom, you can see this is the full packet, the JSON packet that is being formulated in the Python script with all the data we have pulled in from all the different databases and tables the code has run through, so that it can finally be posted. As you can see, this JSON payload to json.dumps, this is the function, and the full packet, as you can see here, this is the full packet that's being sent to the endpoint, and then post to OQLIS endpoint GUID JSON payload, which is this, so that it can then send through to the IoT endpoint and that you can receive it at the other end. So that was the Python code, and now I'll jump into the OQLIS instance and give you a quick overview of how that works, how the IoT endpoint works, how you can set that up, and how you can get your data into your OQLIS instance. Perfect. Now that we are running through the OQLIS instance, we go to the instance, tracking.oqulis.com. And so this is the home screen for our instance. If you go to the left-hand side, you can see the menu options and all the different modules you can access and use within this instance. So first things first, we're going to the IoT modules, what we are interested in right now. As you can see, these are the existing IoT endpoints and recipes we have set up for the tracking dashboard so far. And then before anything else, you go here at the top right. It looks like a USB sign, and this is needed for authentication. If we go back to the Python script, just to give you a reminder, there was a username and a password you had to put in there. That is for this authentication. So you go add new, username, password, connection. This is the connection you have made with the specific database you want to use. Please go watch our other videos on how to do this. So I'm not going to go into depth about that right now. And then you have your sync frequency. That is 5 minutes, 15 minutes, 30 minutes, and 1 hour. So then after you have set up your username and password, we can go to this existing one. I'm not going to show you the password, but yeah, so this is the IoT user. It's tracking password, what connection it is, and sync frequency. So that is needed for the authentication. If we go back to the IoT module, after setting up your authentication, that is the first thing you have to do. You can go to your endpoint list, add new. This is your endpoint name and your endpoint GUID. Your endpoint GUID is a unique name you have to give the certain endpoint. Just to show you an example of the tracker. So this is how it looks like: tracker, endpoint GUID tracker, workspace main. And this is an example of the JSON package that is being sent to the endpoint through the Python code. So data, device data, we have seen this in the Python code, and this is then being built with all the values it acquires by running a loop through our chosen databases and tables we have chosen in the Python code and specified. Going back to the IoT module, we can then go to the recipe list. So a recipe list is what we use to take that JSON packet and to flatten it into a nice table setting. So as you can see, or what you have seen from the JSON packet, it's not very nicely formatted, so you can't really pull insights from it directly. So what a recipe list, or what a recipe does, is let's go into tracking metrics right here. You can see that the JSON file is getting pulled in, and all of this, entry time, endpoint good, these are names that we have in our JSON file. So things we are pulling in. And what it makes it very intuitive is that you can choose a conversion. As you can see, a device data date converted. Since it's Unix time, it only gives integer. So now we can go to device data date to see exactly how it converts that Unix time that we were talking about. Yeah, so here we have it. We can press on convert. As you can see, there's already a convert added. It's date converted. That's the one we saw at the bottom, from Unix time device data date. And then it converts it into a very nice looking column that specifies your year, month, and date, and not just a list of numbers that don't really make sense since it's converted from your computer. So that is the three things you need. Going back to the IoT endpoint. So remember, authentication first, endpoint, and then recipe. And then you can run your Python code again, and it will work perfectly, or should work perfectly this time. So after all that, we can go to our data model right here. And then from the data we pulled in and the connection we have with our database, we can create a data model, as can be seen here. So this is selecting all the data and then formatting that and manipulating that data to meet our needs even more. So as you can see here, order by, full day, ascending. So this calculates the difference between what was the number today versus the number yesterday. And it calculates that different if it increased or decreased. So you can take a look at how that SQL code is looking like and how it was formatted. And then from there, so let me give it a run so you can see how the table looks like. So this is the table: full day, entry ID, entry time, endpoint good. We have our domains for the instances: endpoint name tracker, endpoint good. So this is the unique name, date converted, automation. So these are all the values we have pulled in, database, endpoint master, endpoint recipe. All of this is added, plan type, schedule dashboard. And when we go to the right, these are the columns that we have added: diff, automation, diff. So this calculates the difference between today and yesterday. So yeah, so it makes it very easy to pull your data from there. So when you have set up your data model and it's ready to run, we can then go to explore to build your different explores. There is a separate video on that. I'm not going to go into depth about that right now, but I'll go to the dashboard and show you exactly how it looks like by following all of those steps, and then finally pulling in the data, creating your explores. So these are the instances, workspaces, user profiles. You can see all of this, and then dashboards, automations over the entire Oculus. And so here's an example. And if we go in here, so all of this has been custom coded with HTML. It's embedded with custom HTML. So settings, HTML, override content with HTML. Yes, we want to do that. And then it's all HTML embedded. So you can write CSS and JavaScript as long as it's embedded in an HTML style. So when we go down here, this is the formatting we do to get the color, the rounding of the edges, as well as pulling in the data from what we need, as well as having a click event and adding click logic. So let me quickly go back, show you that. So we added the second KPI, which is also a single value KPI with custom HTML embedded. And what then happens is this is a button. You can see that lifting up on the on the one there with the green arrow on the data models. So when I click that, it then activates this second value KPI. So